Hello, everyone. I'm back with another video on financial markets, implementing machine learning or deep learning on stock price prediction or forex price prediction. So today we're going to cover three very important concepts in the financial markets when we apply machine learning to the financial market. So these are very important concepts and it can make and break of your project. So one of them is a train test split, how to do the train test split, and scaling, how to do the normalization, and finally, how to shape your data. So some of these concepts are so important that I have rejected many papers based on that. And in your literature, you see many papers which would have used the wrong methods, which I classify them as wrong method, and I shall prove you why are they technically wrong methods and those methods being used and the paper being published out there. So I call these papers just useless rubbish papers. So let's get started now. Okay, so I'm also gonna show you some code and some examples. So in our previous video, we downloaded the data from Yahoo Finance, and I've shown you how to label the data. So now going forward, doing train test split or before the normalization or shaping, you must understand the labeling. If you haven't learned that, go back, watch that video, come back. Okay, now we have learned how to do the labeling. There are many ways to do the label. Now, you also need to remember how did you label it. Different people will label differently. For example, let's remove these three things, start from the scratch. So one simple way is you might have done the labeling based on the first cell. Like you looked at the cell ahead. For example, you could have said that if the price of E12 minus E2 is divided by E2 is greater than 0.001, then it's 1, I'll say 0. So basically, you have gone forward, you have gone in the future, and looked at the price there, compared the price that you have at the moment today, and then you label based on that. That's one method. We see many other methods. Other could be that you have, like, for example, starting from here, you haven't labeled these cells, and you start from here, and you say, look at the price, go back in the history, and basically you can say that the price, what's the price for this cell is E11, let's say E11 minus E2 divided by E2. Basically, I'm labeling today, go back in the past, look at how much the price have been changed, and then label based on that. If it's go above 1% or 5% or 4%, whatever threshold you want to apply, whatever algorithm of labeling you want to apply. So then you apply, you continue to do that, right? So now in this case, you have labeled this row based on your historical prices. So now what you want to do is basically looked at on this day, on 26th, you want to be able to predict this day. Yeah. In this case, this data will be useless, but I don't recommend this method. I think the best way is to do the other one, which we've seen before. Well, let's do one. Let's do the other labeling. Or just for the sake of going fast, let's do 0, 1 manually, whatever. 0, 1, 0, 1, 2, 3. Get rid of this one. Let's get rid of this one. Okay, let's do a quick labeling again, and I recommend you do the labeling this way. Looking into the future, if the price on, for example, E11 minus E2, there should be, sorry. The price of this day should E2 divided by E2 is greater than 0.01, then it's 1, otherwise 0. Yeah, I think that's the better way of doing it. Now you basically have gone in the future, looked at the change of the price, and then you have labeled it. So now you need to remember that how many cells have you jumped forward. So this was basically 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So that could be 10, that could be 11, that could be 20, whatever. Now, now the next thing very important to understand is scaling. How do we do the scaling? And I've seen many people doing the calculating the technical indicators and then scaling the whole data. So in a one go. And that's wrong. That's absolutely wrong. Why is that? And let me explain that. So in this 1 years of data, the price in the beginning of last year was 243, and now it has gone up to 404. And one of the very commonly used scaling method is a min-max scaling. Or even if you do other type of normalization, if you're using the all data set in a one go in the financial market, that's absolutely wrong. And I have rejected papers based on this fact. That's absolutely wrong. Why? Because you're utilizing the future data in your training, which you can't do. It's a data leakage problem. Just to explain one method, min-max method. In the min-max method, you calculate the max of all the data in this row. So what's the max in here? Is 404. And what's the min in this one? In this one, the minimum starting from here. The minimum is 200 on this row, right? So if that I change this manually. So if this was 122, so that's the 120, then this is going to be your minimum. And if you're doing the scaling based on these min-max factor, and if the minimum or maximum is in the future, and you scale all of your each feature based on this fact, that means you're using that future information into your training, and that's absolutely not allowed. And that's why many algorithms that are developed in the lab, they don't work in the real market when you apply it on the onto the real trading, or when you do the backtesting, the real backtesting, right? So how do you do that then? I'll explain that part of the shaping mechanism. One simple way, which is I'm not even in favor of you scale, train, test, split separately, but again, that's not the best way to do it. And I explained what's the best method, part of the shaping. So let's look at the shaping, and then we can go back to the concept of scaling. So the shaping, why is important? The shaping is one way to do the machine learning algorithm is these are your features. Usually we don't use data as a feature. So these are your features. You calculated a number of technical indicators. That's fine. So one simple method is all of your features is basically you just take these features and then you load that label in your machine learning or deep learning application. That's absolutely fine, but this is not going to work well. I assure you this doesn't work well. You can do that. I don't see any problem in there, but usually it doesn't perform very well. The way it has a likelihood of performing well when you take into account some historical data, right? So in that case, then you choose a number of features, and when you're able to do that, you can take 10 days of data, you can take 20 days of data, whatever you feel like. For the sake of easiness, let's say we take 5 days of data, okay? And then you put them into to explain that I paste in the Microsoft Word. So basically now all of these features going as a row, right? Have a look again. So each row here represent a row of the data frame, right? So in each row, I'm gonna put all of these features, yeah, like this. And against all of these features, now this is your label. This is your label. That could be 1, that could be 0, or that could be the number, whatever. So what we want is to machine learning to, based on all of these features, want to learn that label. And then in the next cell, let's do a color to this one. We put a color here. And then you do the next 5, and copy them and move into the next row. And then you have a label for it. That would be 1 or 0. That would be 0, for example. Right? So you take the labels from here and you continue to move these basically historical prices. Now, so that also means, because you're choosing the 5 days last value, so that means when you have taken these 4 numbers or 4 rows or 5 values, so you won't be able to do the prediction until 2nd of February. Like on 2nd of February, you've taken the data for the last 5 days, and then you predicting the future value, right? So now going back to now, how do you do that in the Python? I've got a Python file here, and that's the function I've written for the shaping. Basically, it's converting data into the 2D. This function is available in my GitHub. There are lots of code in there. Somewhere it is available in there, or you can just stop the video here, take a screenshot, you can write it yourself. So that's a full deep learning, basically an example that I've covered in another video. Here I'm just focusing on these 3 concepts: how to do the train test split, the shaping, and scale. Now, so the data in this function, where we pass all the data, we pass our labels, and we define how many days we're going to be using to predict the future. We take the last 5 days. In this, for example, we take this last 5 days of data, and then we try to predict. So we generate 2, basically X and Y, and then we do a loop, and we jump ahead that many number of days. We take the labels out of it. So remember, you need to tweak that function based on how you would have labeled it. So we grabbing the label here on the Y one, and then we feeding the last days of data into the X, and then finally when you check the shape, it will come across like that. That many number of features. If you want to apply the CNN type algorithms to this data, then you would need your features to be shaped like that. And your labels go as a separate vector. And if you, in the Python, if you just print the shape, it's going to look like this. Now comes the scaling. Now, so what I believe the best way to do the scaling is this. Now you scale each row here individually, irrespective of the previous row and the future row. So you do whatever scaling you want to do. I'm fine with any type of scaling, standard normalization, min-max scaling, or whatever type. But you only do this one. And why that's important? Because you're not using any of the future value here. So if we want to predict what's going to happen tomorrow, we only take the last 5 days of data, and we do whatever we want to do with this data. We can do any type of scaling, any type of normalization, and then we predict the future. That's how it's labeled, right? And one of the way that I came up with, I published that a few years ago in one of our paper. We call it the row-wise scaling, right? So, and that performed very well. In my paper, I have shown you do apply different type of scaling, and this is the best scaling that will work out of all standard type of scaling out there. So in each of the row, you take the maximum, like in this one, in each of that's full row. In each of the row, you go for each column, you take the maximum of that column, and then you divide by that maximum. So in each of the row, take the maximum, and then divide all the numbers with that maximum. So I call it the row-wise scaling based on that. It's getting implemented on each of the rows. So for each row, you will have a different maximum. Yeah. So this is the code here. It's just 2 lines of code. You can just print and check. And for the train test split now, is very important. People do random train test split. But I think for the deep learning application, you definitely need 3 split: train, validation, and test. For the machine learning, you can do train test split. But I think it's very important that you take the beginning of the data as your training, and then the next set of data as your validation, and then the most recent data you take it as your test data. So in this one, I'm only doing the train test split. The beginning of the data, 80% of the data has been saved into the training, and then the last 20% being used as the test data for this example, right? But for the deep learning algorithm, you should you can have like first maybe 70% training, and then 50% validation, and another recent 50% as your test data. So these are three very important concepts in any machine learning, deep learning algorithm when you implementing them on the stock or financial markets. So I hope you have learned something from this video, and see you next.